Okay guys, this is going to be a real quick demonstrations of Arduino board LED control using a push button. So here we go. So first we're going to declare our variable for the pins that we're going to use. Variables. Then we have we're gonna declare the pins for the button and the pin for the LED. So we got a constant integer and we call it button pin, and we assign it to pin number 2, and another constant integer LED pin, and we call it for pin 8. Then we're going to define that is going to hold the value for the state of the button, the pin where the button is attached. So we call it integer button state, and then we initialize it to be equal to 0. So that's all we have there. So we got a constant integer for the pin, and then for the LED, the button pin and the LED pin, the button pin set to pin number 2 and the LED pin to pin number 8. And then we have the variable that will hold the state of the button initialized to 0. Then we go to this Arduino setup. So basically here we're just going to define the pin mode, which is an inbuilt function for Arduino. So pin mode, we say the button pin. What do we set it? We set it as an input because it's going to be looking at the state of the button, so it's an input. And then another pin mode, and that is going to be the LED pin. And then this one, since it's going to output something to our eyes to see, then we set it as an output. That's all we have for the setup. Then we come for the loop. This is the main loop for the Arduino. It's going to run forever as long as you don't reset it or you pull the plug. So here we go. So we first define that button state, what it's going to be looking at. So we say the button state is equal to, we do a digital read. Now a digital state from the pin, whether it's a low or a high. So when it see a high, which is a voltage greater than 2.5, then it's going to register a 1. If we read the voltage that's below that, then it's going to register a 0, and that will be assigned to the button state here. So what we're going to read here, we're going to read the button pin. So we put button pin, semicolon. Then the next thing we do our checks, if statement. Okay, so what do we put in the if statement? We checking the state of the button. So we say if the button state is equal to 0. That means if this pen is reading digital read is reading low to the pin, then what do? We do a digital write. With digital write, we are writing what? We're writing a high, we're writing a low to the LED pin. So we say LED pin, we write low. Then if it's not seeing a high, what do? If it's not seeing a low, what do? We write something else. So else digital write LED pin high. So that's basically it. So we're gonna read the state of the button. We will check here. If it's a 0, that means the low on that input pin, then we're going to turn the LED off. Now if the state is high, else, yes, then it's going to be high. Either then low, then it's high. So basically at start, we already initialize the state here to 0. That means the LED will be at 0 even without us doing anything. So basically that's it. So we're going to verify or create the build for the X. So it's going to build it and compile to see if there is any error. At the same time, it's going to create the hex file for us. Okay, the hex file is created. Basically, we're only using 2% of the memory allocated to us. Now we are ready to upload the real board. I've created a simulation circuit that we're just going to demonstrate it quickly. Okay, so here is a circuit that I've already wired up on the simulation. Okay, basically I'm reading the button here from the state of the button on pin 2, which is a PDT. This is Atmega328. It's a same chip that's being used on the Arduino board. So here the switch is in the open state, the push button. Now you can see this pin is being pulled low by the 120K to ground, so it's seeing a 0 there. If we press the button, then it's going to pull it high. And then we have an LED just attached there. Now the LED is 150 ohm. That is to limit the current, because you don't want to draw too much current here, otherwise you're going to destroy that pin. So you must ensure that you get a real calculation. I calculated already to get a 21 milliamps of current flowing into this pin here. So the way you do that is you subtract the voltage drop of the LED. So this is a red LED, which means according to data sheet of most of these LEDs, the approximate voltage drop is around 2 volt or 1.8. So assuming that I got a 5 volt there, so I make 5 minus 1.8 is 3.2. Then I divide it by the resistance, which is 150 ohm in this case. So I got 21 milliamps. So there will be 21 milliamps that will go down there. So basically that's it. You have to ensure load the hex file that I generated from my program, and then I run the simulation. You can see the program starts, simulation run, but everything is at a low. It's a low here because it's detecting low here and the LED is off. As soon as I press here, it's now detecting a high on PD2 and it's outputting a high there. So that's basically it. You can play around it. So this is a simulations of how that code operates inside the chip. Now I've got it wired up on a breadboard, and I'm going to also demonstrate it quickly. And that's the resistance that is connected to the LED for limiting the current. It's not 150 milliamps, it's a little bit less. That's what I had here. And this one here is it's a 1K resistance that I'm pulling up with this red wire that's connected to VCC, and that's my push button. And this is a 120K resistance that's pulling the pin to ground to when the switch is open. So that's basically how the connection is done. Very simple. So I'm going to demonstrate. If I press the button, then the LED come on. As simple as that. So basically that's it, and how you simulate and do a real implementation of an Arduino push button with the LED. So if all of this was any useful to you, please don't forget to like, subscribe, and share. That's a motivation for more videos like this coming. Thank you. Cheers.